Hello everybody. We start with a new chapter in chemistry. In fact, it is a part and a parcel of the chapter number 3, that is acid, base and salts, but it is not connected to it too much. Anyways, so this chapter is analytical chemistry, that is analytical chemistry using ammonium and sodium hydroxide. In chemistry, whenever you are doing any practical, okay, the practical will result into two kinds of the observations. One will be the qualitative kind and other one will be quantitative kind. So one is qualitative, other is quantitative. Qualitative means that you are talking about the anions present, cations present, what is the color. So when you are talking about the different kinds of constituents of that element, so experimentation, say if you are trying to find out that what are the constituents of the element, then what we are doing is qualitative analysis. If you are trying to find out that kitna ye hai, like if I tell you that in sulfuric acid what is the amount of sulfur in it, or what is the amount of oxygen in it, or what is the amount of hydrogen in it, so we are talking about the quantity of that particular element present in the compound. So that gives you the quantitative analysis. Okay, या for example अगर मुझे 1 liter of water चाहिए तो मुझे कितना हाइड्रोजन और कितना ऑक्सीजन लेना पड़ेगा, या तो एक पर्टिकुलर चीज को मैंने बर्न किया और उससे अगर मुझे हाइड्रोजन मिलने वाला है तो हाउ मच अमाउंट ऑफ हाइड्रोजन आई एम गोइंग टू गेट. सो ऑल दीज विच आर कनेक्टेड टू द amount of something going to be given to you is given by quantitative analysis, whereas the one which tells you about the kind of the elements present in that particular compound, that is the qualitative analysis. So this chapter is basically about the qualitative analysis and not about quantitative analysis. The quantitative analysis we are going to study in the next chapter, that is stoichiometry. So this is what we are not going to study today. We are going to study is qualitative analysis, which is going to take place. So analytical chemistry deals with experimental study both by qualitative and quantitative means. Qualitative analysis includes identification of unknown substance by chemical tests. Chemical tests include use of sodium and ammonium hydroxide on salt solution and observation of the color and solubility of the precipitates formed. So what we are going to do here is we are going to use two laboratory reagents. One is sodium hydroxide, which is NaOH, and other is ammonium hydroxide, which is NH4OH. So these two, NaOH and NH4OH, will be used along with certain salts, and accordingly whatever is the resultant color of the compound or color of the precipitate, or whether it is soluble, insoluble, जो भी result आएगा, that is what we are going to study, and we are going to identify that what kind of salt was used. So this is what we are going to study in analytical chemistry. Now why we are using this two is because this is a strong alkali and this is a weak alkali. So normally displacement, the double displacement reaction can take place only when you are taking either a strong alkali or a weak alkali, depending upon the salt which is used. So sodium hydroxide is a strong alkali which dissociates completely to furnish OH ions, while ammonium hydroxide is a weak alkali which dissociates partially to furnish sufficient OH ions which precipitate insoluble metal hydroxide. So when you are going to use this thing, so this one and this one are both are going to give rise to the insoluble hydroxide. So the insoluble hydroxides which is going to be formed will be the precipitates, and these precipitates will have a peculiar color or some kind of identification which will be available to us to identify that what kind of the cation was present in this particular salt. Now, it is seen that the cations and anions, they are such that many of the cations and many of the anions are such that they are colored, and that color which is present in of that cation identifies or helps us to identify the particular element. So a salt is generally colored of its, if its cation or anion are colored. If cation or anion is colored, automatically the salt will also get the required color. Salt of elements of groups in the periodic table, that is 1, 2 and 13 to 17 are normal elements, are generally colorless. So we see that group 1 elements, group 2 elements, group 13 to 17. So basically we can say that all the representative elements, all the elements which are coming under the category of representative elements or normal elements, they are the one which are normally colorless. They do not give you any color and they are colorless. So that's why identifying those kinds of metals or the non-metals will be slightly difficult, because they do not give you any color. So the representative elements, that is group 1, group 2, group 13 to group 17 are the colorless kind of elements. Group 3 to group 12 transition elements are generally colored. So it is always seen that the one which are from group 3 to group 12, okay, that is the transition elements of the that is in the periodic table, are the colored ones. So the examples of the colored ones are the copper ion. The copper ion Cu2 plus is in the 11th group, that is a blue or green color. Chromium is green color. Magnesium, manganese is pink color. Iron 2, that is ferrous is green color, whereas ferric, that is Fe3 plus, is yellow or brown color. Cobalt is blue or pink, and the nickel is green in color. So these are the colored cations. So colored cations will be copper, chromium, manganese, iron, both ferrous and ferric, cobalt and nickel. Whereas the colorless cations are those which are in the earlier part, that is sodium, potassium, magnesium, calcium, barium, aluminium, tin, lead, zinc, cadmium, mercury and ammonium. All these are colorless. Now in case of chemistry, remember one thing, colorless doesn't mean transparent. Colorless means white. Even white comes, transparent is also colorless and white is also colorless. So when I have anything which is white in color, like we know that sodium chloride common salt is white in color, so it is colorless. We consider it to be colorless. Lead is colorless, zinc is colorless. All these are white precipitate. They are going to give you white color precipitate. That doesn't mean that the white is not a color. For chemistry, in case of chemistry, we consider white to be as colorless. Whereas colored anions will be permanganate. Permanganate is pink or purple in color, and dichromate is orange in color. Whereas the colorless anions will be the sulfate, carbonate, chloride, bromide, nitrate, bisulfite, bicarbonate, oxides, sulfides and phosphates. So all these are the colorless kinds of anions. So yeah, you need to remember this thing so that you are able to identify easily. Of course, जो colorless है उसको याद करने की जरूरत नहीं है कि normally all the colorless will be easily understood, because जो colored है उसको याद करना ज़्यादा easy है because they are smaller in quantity. So if you remember the colors of the ones which are the colored ones, then automatically the others are, you can consider it to be colorless. So now we see one by one the reaction of the salts with sodium hydroxide. So let's see one by one the qualitative analysis, wherein we are going to see how the sodium hydroxide is going to react with certain salts. So the first salt what we are going to take is a calcium salt. So the first one is calcium. So we have over here CaNO3 twice plus 2NaOH is going to give me over here as 2NaNO3 plus CaOH twice. Now this is going to give me a precipitate. So the precipitate what is going to be here is calcium hydroxide. Now this calcium hydroxide, now what we are going to do is we are going to do this process in two steps. One step is you are just going to take the calcium nitrate. So we took calcium nitrate and to that we added sodium hydroxide. After this, so you will be getting either precipitate or no precipitate or some colored precipitate, something or other thing what you are going to get. So that reaction or that particular observation is going to be seen, and after that we are going to take some excess amount of this NaOH and put inside and see whether अगर excess amount डाला तो उसके बाद में वो soluble होता है कि नहीं होता. Okay, so if it is normal amount of NaOH then it may not be soluble, but if I put excess then whether it is soluble or insoluble. So that's why you are going to take this thing, and then this one is going to be, so see here we are not taking this and taking excess of this, we are going to take this and taking excess of this. So the next reaction will be CaOH twice, and then you are adding to the CaOH twice the excess of NaOH. So with excess of NaOH, so with excess you will find that still it is insoluble. So it is seen that even on taking excess amount of NaOH, the precipitate will not be changing and it will be still insoluble, and the color of the precipitate is white. So we understand that calcium hydroxide gives you a white colored precipitate. Okay, calcium hydroxide gives you a white colored precipitate. So when you are having any salt and you are adding NaOH to it, and if the precipitate so formed is white in color, one of the chances of the cation present over here is calcium. Why is I am saying one of the option? Because white बहुत सारा होता है, इसीलिए one of the option in white color is calcium. We take the next example, and that is magnesium. So we have over here MgCl2 plus 2NaOH is going to give you MgOH twice. Sorry, it will be NaCl first. So 2NaCl plus MgOH twice. You can see again Mg is a part of the colorless one. So again what I am going to get over here will be a precipitate which will be white in color. So yeah, this will be white in color, and here it will be dull white. It is called as dull white. So when you are writing the answer, you can write the answer to be dull white. So we are more precise in telling that what kind of color it is. So it is a dull white color, and when you add excess of this thing, so when you are taking in excess, then excess में क्या हो जाएगा? It is still insoluble. So the magnesium chloride or magnesium sulfate or anything, magnesium salt, if I take any magnesium salt and react it with NaOH, I am going to get magnesium hydroxide over here. The magnesium hydroxide so formed will be white in color, and this particular one will be dull white, and it is not soluble in excess of NaOH. So even if you put some more amount of NaOH to it, this MgOH twice is going to remain insoluble. We now move on to the next one, and that is ferric, that is Fe2 plus, so that is why it will be SeSO4. So ferrous sulfide, so it is ferrous sulfide. So FeSO4 plus 2NaOH is going to give me 2Na2SO4 plus FeOH twice. Okay, so this is the reaction, Na2SO4 plus FeOH twice. Now this FeOH twice is going to give me a precipitate, and as I had seen earlier in the table that ferrous is always going to be dirty green, so green color. So इसमें specific करके क्या बोलेंगे? Dirty green color. So the color of the precipitate will be dirty green. So this is very prominently seen. Dirty green मिल जाएगा, खत्म, बात खत्म. It is nothing but a ferrous kind of a salt. So it is easily identified to be as a ferrous salts. And again, when I put excess of this thing, on excess it is still insoluble. So insoluble in excess of this particular hydroxide when putting inside. So FeOH twice, when it is reacting further, if I add some more amount of NaOH to this solution, it is going to still remain insoluble. The next we see is ferrous. This was ferrous, now it is ferric. So now it is ferric, so it will be FeCl3 plus 2 NaOH. Okay, it is 3 NaOH because FeCl3. Yeah, it is going to give me 3 NaCl. Okay, NaCl plus FeOH thrice. Okay, it is going to give me FeOH thrice. This iron chloride, that is the ferric hydroxide. This is the ferric hydroxide. This was ferrous hydroxide or dirty green. The ferric hydroxide is red in color. So it is reddish brown. So it is reddish brown. Okay, so the color of this thing, ferric is red. Rick red. Remember red. Ferric red. Rick red. Okay, Rick red. Rick red यानी क्या? Ferric वाला जो है वो red है, तो ferrous automatically dirty green हो गया. Okay, so Rick red is what I remember it as. So ferric is going to give me reddish brown colored precipitate, which is again insoluble in excess. So it is insoluble. If you put some excess amount of NaOH to it, it is still going to remain insoluble. So these were the first five. Now first four. Now we go to the next one, but I will erase the previous one so that I can get place for writing it properly. So I will just repeat this one again. Calcium is going to give me calcium hydroxide, which is a white colored precipitate, which is again insoluble in excess. Magnesium again gives me dull white colored precipitate, again insoluble in excess. Ferrous, FeSO4 will be ferrous hydroxide, will be dirty green, which is insoluble in excess. And ferric is going to give me ferric hydroxide, which is reddish brown in color and insoluble. We now see the next one, and that is copper. Now you see is copper sulfate. So copper sulfate, it is CuSO4 plus 2 NaOH is going to give me Na2SO4 plus CuOH twice over here, right? This is, now this one over here is again a precipitate which is a pale blue color. It is a pale blue colored hydroxide. So copper hydroxide is a pale blue color, and when I put it in excess, so when I put this in excess of sodium hydroxide, it is still insoluble. So this is the property again, that copper is going to give me copper, when I take copper sulfate, which is blue in color. Now copper sulfate is blue in color. You can see all of them are originally also the color of the salt is also given over here. That I just missed out that thing, that calcium what we used was white in color originally. Magnesium was also white in color. The ferrous, which gave us the dirty green, also already was green in color. The ferric, which was FeCl3, was already brown in color, which gave me reddish brown. Now this one was blue in color. This was blue in color, and it gave me pale blue colored solution. So sorry, pale blue color precipitate. The next one is zinc sulfate, that is ZnSO4. Now ZnSO4 again, it is white in color. So white color ZnSO4 plus 2 NaOH is going to give me the same thing, Na2SO4 plus ZnOH twice. So this is again going to be white in color, but here it is specifically given as gelatinous white. Okay, it is gelatinous white. Okay, the color of this thing is gelatinous white, and this again is insoluble in excess. So when I put this, sorry, this is the unique part about zinc, and that is, in case of zinc, when you are going to react it further, so when you react further with NaOH, it is going to give you a precipitate. It is not going to give you any precipitate, and it is a soluble kind of a colorless source. So here we see that zinc hydroxide, so it will be ZnOH twice when it reacts again with NaOH, okay, that is ZnOH twice plus 2 NaOH is going to give you over here, that is, this is your taken in excess, okay, this gives you as 2H2O plus Na2ZNO2, okay, so that gives you as sodium zincate, okay, it gives you sodium zincate. So sodium zincate is a soluble salt, and hence what you get in excess, so in excess what you get is soluble salt. So that's why you don't get any precipitate at all, you get a colorless solution. So this is going to be a soluble, hence it is colorless. So it will be colorless solution what you are going to get. So when you are going to take zinc sulfate, it gives you zinc hydroxide, which is going to give you a gelatinous white precipitate. This gelatinous white precipitate, if you react further with NaOH in excess, then it is going to give you as sodium zincate. Now sodium zincate is a soluble salt which is going to give you a colorless solution as the end result. The next one is lead, so that is why we are taking over here PbNO3 twice. So PbNO3 twice plus 2NaOH is going to give you over here as 2NaNO3, yeah, that's 2NaNO3 plus PbOH twice. Now this again is going to be a precipitate which is going to be white in color, but it will be specifically chalky white, okay. The kind of white what we will be having will be chalky white, okay, like a chalk. This is chalky white soluble, and this chalky white is not soluble. This chalky white precipitate what you are going to get is going to be again soluble when I put it in excess. So here if I see further, I get over here as PbOH twice plus 2NaOH is going to give me 2H2O plus Na2PbO2, okay, that is going to give me as sodium plumbite, okay, PbO2, that is sodium plumbite. So sodium plumbite, and sodium plumbite again is a soluble kind of a salt, and hence see very well, if you remember that when we studied the acid base salts, we said that all the sodium salts are soluble. So if you have a sodium salt, this is a sodium salt, it has to be soluble. Hence you can see that the zincate what is formed, or the plumbite which is formed, will be soluble, and hence it will going to give you so it is soluble and it gives you a colorless solution. Is it clear? So you see here that the zincate, because it was sodium zincate, that's why it was soluble. Similarly, the plumbate, because it was a sodium plumbite, that's why it was soluble. Another important thing what you can see over here, or you can identify over here, is that the zinc and lead both are amphoteric substances. If you remember amphoteric, what are amphoteric substances? Amphoteric substances are those substances whose oxides and hydroxides can react with acids or bases to give you salt plus water. So you can see over here this PbO2, this is actually, अगर हम लोग OH के पॉइंट ऑफ से देखेंगे तो हम लोग को लगेगा कि ये तो बेस है और ये भी बेस है, तो बेस प्लस बेस में को कैसे मिलेगा? But you can see when this is PbOH or PbO2, this Pb, lead or zinc, ये दोनों का property क्या है? They are amphoteric. So these oxide or hydroxide of these, there is another one which is aluminum. Aluminum also reacts the same way. So zinc and lead का hydroxides, when they react with the alkali, they are going to react as an acid and it will give you salt plus water. That is salt plus water. You can see salt plus water. Okay, the salt what you are going to get will be sodium zincate and sodium plumbite. So you see over here that the amphoteric substances like Pb and Zn and even Al, they will always react. So amphoteric oxides and hydroxides will react with the alkali to give you, it can react with salt, acids also to give you salt and water, but it can also react with alkali to give you salt plus water. So this property of the एम्फोटाइक सब्सटेंसेस आर यूटिलाइज्ड ओवर हियर टू आइडेंटिफाई दैट यहाँ पे जैसे ही मैं अगर NaOH यूज करूंगा तो आई एम गोइंग टू गेट अ व्हाइट जेलेटिनस के बदले एक कलरलेस सॉल्यूशन, हियर चॉकी व्हाइट के बदले एक कलरलेस सॉल्यूशन. ओके, सो दिस इज हाउ आई एम आइडेंटिफाइंग द लेड और जिंक. So that was the 7 different kind of ions which we identified by using the ammonium hydroxide. Now we see the next thing, and that is the reaction with sorry, that was with sodium hydroxide. Now we see the reaction with ammonium hydroxide. The same, we are going to use the same compounds, that is calcium, magnesium, ferrous, ferric, and copper, zinc, and lead. So we see over here. Or I'll do one thing, I'll just take it in the next video so that I'm not halfway when I'm explaining you with the ammonium solution. So let the ammonium part and the next part of the chapter be in the next video. So maybe this is a very small video, but doesn't matter.